Hey everybody, welcome to my video. I'm Alex Merced of alexmercedcoder.com, and this is day 9 of the 100 days of Go and Rust video series. So in this one, what I want to do is talk about structs and struct methods. Okay, essentially OOP in Go and Rust. Okay, now Go and Rust do not have objects. They do not have classes. So it's not like C# or Java where it's everything's a class. In this case, it's kind of quite the opposite. Nothing's a class, and you don't have this sort of bundling of functions and properties, which we are used to being objects. But you can still pretty much do the same thing. It just Go and Rust favor the concept of composition, where you can reuse sort of the same definitions of same bundles of methods across basically more of a build-to-bear approach. In the sense, I'm going to say, hey, I want this object, this thing that I'm creating, to have these properties, these methods, and then kind of pick from different pieces. Okay, and later on we'll talk about, in a future day, talk about like interfaces and traits, which kind of pile on that whole composition approach. Right now we're just going to say define a struct, and a struct would probably be the closest thing to a class in Go and Rust, which is something that goes back to C. But essentially a struct is just a class without methods. It's a definition of properties that are sort of bundled together. And then what you can then do is, in the languages, you can implement functions that work off the struct. So in Go, what you're going to be doing is that you define functions where there's a receiver, which the receiver is some object of a particular type. Okay, right now it'll just be, we just specify a type of struct as the receiver. Later on we can do more fun things like use interfaces, so that way the same function can be used for lots of different things, which makes it, a little bit more dynamic. But we can say, okay, hey, this function can then be used by structs of this type, in the same way you would use like a method for the most part, not really all that different. And then in Rust, what you do is Rust has a feature called traits. So essentially every struct has I guess it seems like it has a trait that is its own name. Okay, because I mean it already has the namespace. So then basically instead of implementing, what you do is you just implement a trait by its own name, and you write functions that are implemented on that type. Okay, and so then the thing will have those traits. Those functions. So let's actually put this into practice. First, let's do Go. So let me clear this all out. Okay, so let's clear out main. Let's clear that out. And first thing, let's define a struct. Okay. And I think if I remember right, I always get confused which is which. So we're going to say a struct like a person. Okay, like I'm a person. Okay. And then we'll just say something like name is a string. And yeah, I think that's right. I think here you have to do something more like, I think it's more like type person struct. Yep. That's it. And this is going to be a string. Why does it do that? Okay, name string, and we're going to have an age that is a int. Okie dokie. And now let's say I want to create, well, first let's just actually show this at work. So I want to create a person. Okay, and actually this is a type, so that should be uppercase. Conventions always that types are uppercase. So type person. And oh, that's the other thing. Because you might want to export a struct, define a struct in another file. Again, right now I can use it just fine in this file, but if I wanted to kind of use this struct in other files, I got to make sure all the properties are uppercase too, or it won't work right when I import it to another file. Because again, things have got to be uppercase to be exported and then imported it to another file. Okay. So it would be more like that. Okay, and then now I want to create a person, so we'll say Alex. I'll create a variable named Alex. So we'll say Alex use the walrus operator so that way I don't have to type it. It'll just assume the type of whatever I assign to it. And then we're going to say a person. And then I think here we just put in the properties. And then I think we're supposed to put like name. Let's forget if it's equals. Let's refer to the documentation. Yeah, so I was on the right track. It's using colon. Okay. Again, I don't use Go and Rust on a daily basis. I'm more of a JavaScript developer. Even Python and Ruby I write fairly regularly. Go and Rust, this is more like a labor of love. I just want to know these languages. Okay, so that's why I do this. Name Alex. Age 36. Okay, cool. And now what I want to do is I want to print fmt.print line and was it S print line F? Where is it? F print line. Or is it just print F? Yep, it wants me to use Alex. I know, I'm gonna get to it. Okay, and let's do this. Percentage, I think would be like percentage S is percentage D years old. If I'm right, S is for string, D is for digit. I might be confusing that with the way you do it in C, but we'll find that in a second. So then I would do Alex dot name and Alex dot age. Okay, because again, this will get injected here, and this will get injected here, and I'm able to do that because I'm using the print F. The F means formatted string, so I'm using a formatted string that has formatting in it. So in that case, I want to manually put in the new line character in there. So there's a new line character. And then let's open up the Go folder. Open an integrated terminal. And then I'm going to say go run.go. And it works. Okay, so I created this struct. That's great. Okay, that's all fun and good. Now, what if I want to use this in a function? What if instead of me having to do like fmt.printf and do all that stuff, it'd just be nice to do a function that I can say, hey, print person. Okay, like just print the person. I could do something like this. I could just create a normal function and you pass a person to it and it prints out its properties. But if I wanted to create it as a method, okay, like a method called stats, I would do it this way. I have to do func. And then here, what we do is we create a variable, that the equivalent of like this. Okay, can I use this? I probably could use this because I don't think this is a reserved word here. This, and then this is going to be of type person. Okay, and the name of the function we'll say is stats. And the only reason I'm using this is just because it's probably something that more people will be familiar with and gravitate towards. Okay, so the func's name is stats, and it takes no arguments. Returns nothing. Okay, and then essentially what I would do is I would just do, I can just literally just copy this. Boop, boop. Only thing the difference is that instead of alex.name, it would be this.name, this.age. Okay, and so basically this, again, is referring to the object itself. Like typical what you'll see in like a lot of other people's like code, they'll do something more like this. P, like the lowercase letter. I'm gonna do this because I just think like people who come from other languages, this will probably speak to you as to what this is saying. It's saying, hey, there's a variable called this that is of type person because that's what's called the receiver. Okay, so the idea is I can use this as a method on structs of this type. So now I can replace this line of code and instead do alex.stats. Okay. And see, it does the same thing. So it's essentially the same thing as having like methods in a class. The only difference is that since you're not bundling them in a class, there's no inheritance. The idea is inheritance is just not a thing in Go. Composition is the thing. Okay, so you, because I can implement the same function for multiple structs. Okay, so if I had, suddenly I created a cat, you know, if I create like a cat struct, okay, we just call it cat. Okay, I can then redefine this function. You can't use the same, well, you can, but we haven't gotten there yet. We haven't gotten to interfaces yet. Okay, but what I can then do is just redefine this function and create a version of it for a cat. Okay, and I can say this, you know, the cat named is this years old. Okay, so now if I create like a cat, we'll call it the mittens equals a cat with the name of mittens and the age of 4. Okay, and then we do, well, that should be mittens, not mitters. Mittens dot stats. Okay, and then this is going to work the same way. So it's the same function, but I can define a different version of that function depending, and it'll use the one that has the receiver of the right type. So watch what happens when I run the code. So see, the cat named Mittens is 4 years old. Alex is 36 years old. So it knows what type my variable is, and then looks to see, hey, is there a method that is of that type? Okay. I think later on we'll be able to use like interfaces to make that simpler, or and generics. So we'll eventually get to that. Like, interfaces aren't so bad. Generics always trip up my brain. I get the idea. It's like a placeholder for the type. But yeah, so that's how you do that in Go. It's not so bad, right? You just, now another cool thing you can do in Go is you can use backticks and you can define certain like properties. Like there's different ones. Like for example, like you might to say, hey, if you were ever to serialize this as JSON, and it really depends on like certain frameworks where you can do this, but you can tag, you can create different tags. Okay. And again, the JSON one's not usable because it's not, I had to create like a particular type of struct because I've done that in like the Buffalo framework. But the idea is you can tag them with backticks and apply certain like properties that are defined, and those will come up when they come up. But like for example, that way, like in string representations, maybe I want the name property to show up as lowercase or something like that for like JSON. Okay, so that's the Go story. Now let's go over to the Rust file. Okay. Now let's just clear this all out. Let's do the same deal. Okay, so let's start with a struct. I think here I just use the keyword struct. So we'll say struct person. And then I would just say like name, and then here I don't have to like do it uppercase, so I can just say name is a string, age is a number, a 32-bit integer. Okay, so there's a person. And then we can declare a new person, so we can say let Alex equal a person do I do it this one, do I use curly brackets or equal sign? Let's double check. What am I looking for? Methods, we'll come back to that. Structs is what I want. Custom types, structures. How do I declare it? Okay, so person, name, age. Well, that's like the shorthand way of doing it. What's the longhand way of doing it? Okay, there's the longhand way of doing it. Okay, cool. So it is colons. Okay, so I could do like name. Then since it's supposed to be a string, so I have to do string from Alex Merced. And then I can do age 36. Okay, do a semicolon. Okay, and now I can go like print line. And I can say name is yada years old. The first thing that we're going to pass in is going to be Alex dot name, and then Alex dot age. Okay, I think that should run fine. So let's open up this folder in a terminal. So again, first I gotta compile it. So rust c run.rs, and then we gotta run the file. /run the compiled file. And see it works. Okay, so I can define the struct just like before. Say, hey, these properties exist on a thing. Now, see, this gets like a little messy because again, there's some things in Rust that takes a little while to define. So if I really wanted to make this like simpler, what I could do is I could actually like declare a name variable. So like let name equal that's not what I wanted to do. Control Z, Control X, Control V, and then we'll say let age equal 36. So again, these need to get semicolons. And then what I could do is that I just pass the variables. So this is like the shorthand you might be familiar with in JavaScript, where you can just pass, if the variables names match the property names, you can just pass them in. And this will generally end up in the same place. Okay, same deal. Okay, you can also define like tuple structs. Okay, and again, tuples are fairly like important in Rust. So I could do something like this. Like if I wanted to define a particular tuple and do something like this, like you know, string I32. Okay. So in this case, I would say, okay, hey, Alex equals. Well, technically, let's not do it that way. So then I think it would be person. We're declaring a tuple. So it would be string from Alex Merced and 36. Okay. So then what I could do is, again, I could destructure the tuple. Okay, but I just declared it, so why would I do that? I could use pattern matching. You might remember from our previous video, so I can say like match Alex, and then just say something like, okay, if the pattern is like name age, because again it's a tuple with two properties, name and age. Okay, then I would print line X is years old. Okay, and then pass in name and age. Then again, we gotta put the catch-all. You know, print line nothing. Okay, and then this technically will do kind of do the same. Should do pretty much the same thing. Unexpected token. Okay. Did I declare the struct right? Oh, I forgot to do a semicolon. That is why. Okay, let's see what I like there. Found tuple. Expected struct person. Found tuple. Oh, that's right. You got to pass in the type of the struct. That makes some. That just clicked. Something just clicked. Got it. So now only do I have to pass in like. Doesn't have to be a tuple per se, but it has to make sure that it matches. I have to specify the type of tuple. So if it's a struct type, I have to specify it. So that explains something with like how the pattern matching on some tuples works. Okay, that just clicked. Okay. Okay, now it works. Now it's just complaining that this is never going to happen because there's no possibility that this is going to be anything other. But would it let me do it without it? Yeah, okay, that's happy. Okay, I mean, that's kind of pointless to do the pattern matching, but again, if I was working with like a tuple struct, that's how you would do that. Okay, cool. Now about methods. Okay, so let me just go back to, let's get rid of this. Let's just get rid of all this. Let's turn this back into a normal struct with properties, with named properties. So I don't really want that anymore. name string age I32. Okay. And now what I want to do is create methods for it. So what we need to do is an implementation block. Okay. So it's going to be under functions, methods. Okay, so you have to create an implementation block and we can define functions in here. Okay. So always like you're going to define methods and implementation blocks, but it's either we're defining methods of we're just always implementing stuff on a struct. Sometimes we can implement traits. We'll get the traits in a separate video. Okay, but I'm going to implement person. I'm going to say, hey, these are the methods of person. So we're going to say that persons, we can have static functions. Static functions don't refer to themselves. Okay, so they're going to be basically, well, we'll show you. A static method. Okay, function, we'll just say exist. Doesn't take any parameters. It's real simple. Okay, and all it really does is print line people exist. Okay, this is a static method because again I'm not defining itself as an argument. Okay, so its own, the object itself or instance itself is not passed in as an argument. So in that case it treats it as a method of the struct on the struct itself, not a method of the instance. Okay, but I can do an instance method as well. Okay, so we'll just use the same thing as we did before, function stats. Okay, and this function does take itself. So you just do add self. Okay, now basically really this is syntactical sugar. So really what I would be writing is a variable called self that equals a pointer to the class, to the struct itself, to the instance of the struct. And self is the keyword for the instance of the struct. And it's uppercase self because it's a type technically, or a meta type. Okay, but sometimes the people in Rust are just so kind and they gave us some syntactical sugar and the ability to do this. Okay, and that's basically, again, you're just making this available. This may seem very similar if you've used Python, and then with Python methods you always have to pass in the instance as the first argument. So now if I do that, then I can do like print line, do the whole, this thing is years old. Okay. Okay, print line is this year's old. Then what I can do, well, that works. So then down here, we can create a variable of a person. Although I think we need some semicolons. Semicolons. Okay, let me just double check, make sure I'm not seeing anything I missed. Well, none of them are returning a value, so I don't need the arrow. Cool. And you can create like a constructor if you want. Okay, so you can create like, oftentimes people will use a static method for a constructor, so you create a method that returns an instance. So I could do, especially just to do that, I can create a function called constructor that takes in a name that's a string and an age that's an I32, and then what it's supposed to do is return a person, and essentially what we do is we just return literally a person of name and age. Okay, and now I have that to act as my constructor. Okay, although then I have to type in the word constructor. Let's change it to make. That's just easier. Okay, so now I can do something like this. I can say, okay, let Alex equal person dot make, and then be like Alex string from Alex Merced. I could use the toString method, but I'm already used to this. Okay, and 36 is the age, so that creates the variable. And then I can say Alex.stats, because again that does receive itself, and it's implemented on a struct of type person. And if I want, I can also use just like person.exist against static methods. So let's try that out. See if that works. To refer to an item, oh, that's right, static methods have to be with the double colons. That's why when we do a string, when I make a string, where did I make a string? Right over here, I use the 2 colons because it's a static method. So that's right. So this should be, and this should be like that. That's technically, actually, new would have been better, wouldn't it? New's even less letters. There's a reason why new's standard keyword for this kind of thing. So new. So let's use new. Okay. Now why doesn't it like that? Oh, I never defined the things. So it'd be like self.name, self.age. Okay, boarding to the previous error, blah, blah, blah. Oh, nope, forgetting semicolons. Ah, so usually I do this when I'm just awake, but now I'm doing this at the end of the day, so, you know, shame on me. Okay. What does it not like now? Function new, expected struct person, found. Okay, so it just wants me to use the word return. There we go. That should fix it. Just think about the difference here. Because see here, they didn't use the word return. So I was expecting it to be like Rust, where it just magically like returns the last thing, but I guess not. So I will explicitly return it. And there we go, it works. So Alex Merced is 36 years old. People exist. So I can use new as my constructor. I have this method stats on the instance, and the person exists. So essentially I can do all that stuff. Again, at this point, it's like, that just seems like a more complicated way to do classes. Once we start getting into like traits in Rust and interfaces in Go, you'll start seeing sort of like some of the benefits of composition. It's still a lot more code, but I mean, it's going to be a lot more code either way because it's a lower level language. And we know that going into it, but it's still not so bad. I would say, having dabbled in C, just like trying to implement my own array methods in C, just to do it, that was a barrel of fun. Now, of course, like I'm sure, like if I used a bunch of utility libraries, C would feel like any other language. But I'm just talking about like, hey, just from using the raw language with the raw tools that it comes with, you know, I can see why I might want to use Rust or Go over something like a C or C++. Okay, because again, you're choosing these for speed. You're choosing this for that lower level compiled language to create something a little bit faster than you can with modern high level languages like Python, JavaScript, Ruby, PHP, etc. So that's it for today. I'll see you all later on in the next day. Ciao.